Okay, good morning. So today we're going to be just overviewing quickly variables, how to form a hypothesis, and what the different types of errors are, as they're quite helpful things to know regarding Unit 4, Outcome 3. Both on the SAC and the exam, the usual way is you mostly get questions, especially on the exam, regarding interpreting data and things like that, but you do still get a few questions that often link to hypotheses and variables. So yeah, that's why I wanted to just overview this stuff again, even though we've looked at it before. So independent variables are variables that are changed by an experimenter. So that's an experimenter actively changing something in the experiment to see the effect on something else. So that's the independent variable changed by the experimenter. The dependent variable is measured by the experimenter, so they're looking for that and they're looking at how it changes. An extraneous variable is anything that is not the independent variable that could affect the dependent variable, and we don't want those. So extraneous variables are not something that we want. And then control variables are things that are kept the same to avoid an extraneous variable. So you could really say that a control variable and an extraneous variable are actually the same thing. The only difference is if we're not controlling it and keeping it constant, it's an extraneous variable. If we are controlling it and keeping it constant, it's a control variable. So we don't want them to be extraneous and uncontrolled. We want them to be controlled and kept the same. Okay? And yeah, when we're phrasing a hypothesis, we want to include the independent variable and dependent variable and make a prediction. So if we're looking at a really simple experiment like how changing the temperature affects the time it takes for salt to dissolve, our hypothesis could be an increase in temperature will affect sorry, let me restart that. We could say an increase in temperature will decrease the time it takes for the salt to dissolve. So I've made a prediction and I've mentioned the independent variable of the temperature and I've mentioned the dependent variable of the time it takes for the salt to dissolve. And the control variables of something like that, we don't mention that in the hypothesis, but that could be things like the volume of the salt. If we're using 1 gram for one group and 5 grams for another group, that wouldn't be fair, it wouldn't be consistent. So we want to make sure that those are controlled and kept the same. Yeah, I've put it at this level because really when you look at science more of a degree level, you'll see that there's the concept of the null hypothesis and things like that, but for this level we won't really worry about that. So yeah, just remember for a hypothesis you want to include your independent and dependent variables and make some sort of prediction, okay? Now on to errors. There are 3 main types of error, and really the third type of error can include the previous 2, but we'll just go through them. So a systematic error is consistently wrong, results in results that are consistently wrong in the same direction. So the value may always be 2 units below the true value, okay? A lot of things can cause a systematic error. Very often they can be due to equipment that's incorrectly calibrated. If you've got a thermometer that's always measuring the temperature as 5 degrees lower than what it is, your results will always be 5 degrees below the true value. So that's a systematic error. And really systematic errors, once they've happened, you can't really control for them unless you know exactly what went wrong. So really the best thing to avoid a systematic error is to make sure all the equipment is proper and the experiment is being done in the most accurate and valid way possible. And then we've got random errors. So random errors are unpredictable variations that lead to values that fluctuate above and below the true value. Now, random errors are really hard to actually control for. A lot of the time, it's almost impossible to stop for them. There are so many things that can impact an experiment. Random fluctuations in air and things like that can affect loads and loads of things. But we can account for a random error by making sure that we do several repeats and take a mean of our results. And that should balance out the fluctuations above and below the true value as we go. And then finally, I've also got the concept of a personal error, which as it sounds is just a mistake made by the experimenter. And that can be random or systematic. And sometimes we don't count it as random or systematic if it's something that just really messes with the experiment. So you can almost think of a systematic error, like if you're baking a cake and you have to bake it at 200 degrees, but your oven thermostat calibrates it wrong, calibrates 200 degrees as 50 degrees. No matter what you do, if you always set your oven to 200 degrees, you will always be cooking the cake 50 degrees too low in that example, okay? An example of a random error when you're cooking a cake could be maybe to get the absolute perfect flavour, you should be putting in 2 million individual grains of sugar. Now, I'm sure you can imagine putting in 2 million grains of sugar is incredibly difficult to do exactly, so it makes more sense to round it to the nearest gram, which won't give you the exact right amount each time, but if you consistently make the cake, going for the amount in grams, it will taste about the same each time. So that could be like a random error. And a personal error could be, I don't know, just not turning the oven on in the first place, in which case you have to make sure that you start again and make sure the oven is on when it's supposed to go in next time. So hopefully that helps as just a refresher of how hypotheses, variables and errors go, and make sure you look at the other resources regarding the practical that the SAC is based on. Okay, thank you.